We'll start with the next program to measure the temperature using sensor, and that sensor is connected to the ADC chip, and that ADC is connected to LPC1768 using SPI bus. So SPI bus is used. This bus is connected to LPC1768, so it has got a serial clock. This is serial slave select. This is master in, slave out, master out, and slave in. These are the pins for this bus. So this is connected to the ADC chip. The ADC, it is an external chip, and that is interfaced with our LPC1768. It is an external DAC, and it is a successive approximation ADC. So it has got channel 1 and channel 0 and D in and D out. This is our digital output, that is after conversion what we are going to get. For successive approximation, we make the MS bit 1 initially, and that is fed through D in. And this is the clock. So the MS bit which is fed initially for the start of conversion is fed on this D input, and the digital output D out is obtained on D out. That is a block diagram. So we have single ended mode, wherein we have the slave differential input and odd sign. These are the 2 bits in this register. You can see here, this is a register here, wherein we have got SGL DIFF ODD SIN, okay, and MSBF. These are the bits in configuring the ADC. So this is used for single ended mode. Then to transmit, this is a 12-bit we have seen here. It is a 12-bit SAR. So 12-bit of data will be obtaining. So we have got these a lower 8 bits and the upper 4 bits are present in this register. So we have got from B0 to B11. So these are the 12 bits of data. So we are going to use this for our program. So in our program, so initially we are going to include the header file, and then this is for standard input output because we are using the LCD that is present on the kit. So we are using this LCD display, so we need a standard input output header file. Then LCD initialization header file is required. Then we are using SPI, so SPI bus is used, so we need an header file for that also. So after including all these header files to your main program, we'll start the initialization part. So you're going to declare the MS bit and the LS byte. So this is MS byte and LS byte. So this LS byte will be of 8 bits and this will be of 4 bits, totally 12 bits of ADC value, that is the digital value what we'll be getting it. So we have here, we have initialized ADC as a 16-bit uninitialized value. Then we have declared temp as a floating point value and a character a string of 10, that is for displaying the data. Now you can see here, initialize the SPI, initialize the LCD. This is the string that will be displayed on your LCD here, raw ADC, and the temperature data whatever you get from your ADC will be displayed there. So you have this raw ADC and then temperature. So this is the main program after initialization. So we have to initialize the SPI enable chip select, okay, give a small delay, and after that you are going to write a 1 to this. So writing 1 is nothing but you are starting your initialize, that is starting the ADC. I told you here D in is made 1, that is the MS bit is made 1. So you are going to load 1 here, that is the start bit is made 1, and that start bit is sent on the SPI bus. So SPI write 01. Then after that you are making MSB as SPI write A0. A0 is SLG is made 1 and odd is 0. This is master slave buffer is made 1. So that means you can see here, this is made 1 to, so that the digital data that is after conversion will be fed to the LPC 1768. That means if it is set to 1, then the ADC will output the converted result to the LPC 1768 on this bus, that is master in, slave out input. So that is why it is initialized as A0. Then you make your LS bit as 000. So you can see in this format, so we have A0 and the remaining bits are made 00. So this is 1 0 1 0 0 0 0. So it is A, and all these bits are made 00. So you will get this as A0. So you will get this as A0, and then LS byte is made 000. Then you disable the chip select of the SPI bus, and after that the data is sent for conversion. That is, you have started your conversion of analog to digital data using successive approximation ADC. And after the conversion, you get back the data from that. So MSB is ANDed with 0F. That means you are masking the upper bits, you are getting only the lowest nibble. Okay, so it is 0F. That lowest nibble is shifted 8 times so that we will get this. So I am going to shift this from year to year. That means 8 times if I shift, it will come to this format. So I'll be getting my MS bit in this position. You can see here the this is the MS bit position. So the MS bit is shifted 8 times. When I shift it 8, I'll be getting this format. So that means the value is loaded to the most significant nibble. So it is shifted 8 times, and then it is ORed with the LSB value, that is LS byte value, and this value is stored in ADC value. So once I get my ADC value, that will be displayed by using sprintf on the LCD screen. And the temperature value is calculated as the ADC value into 3.3 divided by 4096, that is because it is a 12-bit ADC, into 100, and that value will be displayed on the screen. Okay, so that is how it looks after executing that program. You are going to get this on the screen. Okay, so we will see how exactly you are going to execute that program. So we have the ADC program piped in this window. Now we are going to add to the source file ADC. This file you are going to add along with the system file. So once these files are added to this, you need to add the LCD files also to this. So I am going to add the LCD INT file, add this, then you have your SPI bus, this also should be added. Okay, and you make sure that wherever you are working, in whichever folder you are working your program, you should have your header files also, header files corresponding to LCD and SPI. You can see they are header files because I have selected here as .h files. So it is LCD INT and SPI.h file is also present in the same work group. So after doing this, you set for the target. Options for target, go to output, click on this in order to generate hex file. Go to linker, click on use memory layout from target dialog and say OK. Now once all this is done, you save this and then compile. Once you compile, in case if there are errors, after correcting the errors, so you compile once again and then once you do the compilation, you should get 0 errors and 0 warning. Now the X file is created. This X file is ready for dumping onto the kit. Once you dump onto the kit, you make the following connections, that is the flat cable connections on the kit. You are going to connect J5 to J25 and J29 to J20. So we are going to connect these two flat cables, and then download the program using Flash Magic onto the kit, then run the program. So once you execute the program, you can see this display. Now this is the temperature sensor. If you just hold the temperature sensor, the temperature is sensed, that is the finger temperature is sensed by this sensor, and you can see the increase in your temperature here, and that will be displayed on this. This is about ADC